Hi everyone, today you're going to learn how to calculate surface area. So you have been learning how to calculate volume, which is the total amount of space taken up by a 3D solid. So you'd measure them in those little centimeter cubes maybe, or another type of cubic measurement where you'd imagine it being filled and your formula is length times width times height, and you're calculating volume. So today you're going to calculate something called surface area. So surface area is just what it takes to cover the outside of a 3D object. Okay, so imagine that you're maybe wrapping it up. So not the inside, just the outside, the surfaces. So we know that 3D solids are made from two-dimensional flat faces. All right, so for example, this cube is made out of 6 squares. So what you would want to do is you would want to find the area of each face and then add them all up. Now the cube is not a hard one to do because all its faces are exactly the same. So once we find the area of one of the faces, one of these squares, okay, so I'll show you what I mean. So there's one square that would make up the face. All right, to find the surface area, we would have to find all 6 of these faces and add them all up. Okay, I'm going to show you the net for the cube. So again, we see 6 squares here that are all the same. So surface area would be to add up all the areas of those squares and put them all together. And that would be what would wrap around the outside of your 3D solid. Okay, so I'm going to give you the dimensions here of this square. So one of these square faces has a length of 8 and a width of 8, okay? So we are looking at one of the squares is equal to 8 times 8, which is 64 centimeters squared. Now, again, the cube is kind of an easier one to do because once I know that what the area of one of these squares is, I know that there's 6 altogether, so I just do a little math and multiply it by 6. So 6 times 6 is 36, 38, for a total surface area of 384 centimeters squared. So remember centimeters squared for area. Okay, this is different from volume now. Okay, if you were doing a rectangular prism does not have faces that are all the same. It has 6 rectangles, but they're different. Now we do know that top and bottom will be the same rectangle. The 2 sides will be the same rectangle, and your front and back will be the same rectangle. So if I've actually gone ahead and calculated the area, so top and bottom, now what I like to do is I like to draw myself, and in your book I think they've labeled it for you. So I like to draw myself the different parts to make sure I get them all. So top, bottom, okay, I want my front and back. Those should be the same size. And then you want your 2 sides. Okay, so like a cube, it has 6 rectangles on it. Okay, we know that a cube is a type of rectangular prism, so that makes sense. All right, so my top dimensions were a length of 14 and a width of 9, and together 14 times 9 is 126. So 126 centimeters squared for the top. I know that my bottom is the same measurement in a rectangular prism. Okay, I've got a front that's a length of 14, and then that would be the height that I need my width here. So this is 14 by 5, and 14 times 5 is 70. So I know I've got 70 and 70. And then for the 2 sides, I've got 45, which for a width of 9 and a height of 5. So I've got my 2 dimensions that I need, 9 times 5. And I've got my 2 sides that are 45 each. Okay, so now what I have to do is I have to add all of these up together. And I'm actually going to go ahead because I don't want to make a mistake. So what I'm going to do is I'm going to do them in groups of 2 first. So 252 for the top and bottom. Now I know that I can add these two easily enough, so I'm going to go ahead and start my tower. 252 for the top and bottom. Front and back together will be 140, and the two sides are 90. So I'm going to add that up for a total surface area of all 6 of these rectangles. So 2 here, I have 5 and 4, which is 9, plus another 9 is 18, and then 4. So 482 centimeters squared for the total surface area of my rectangular prism. All right, now, it doesn't stop at rectangular prisms. We also are going to be looking at triangular prisms when we're finding surface area. So you need to just remember your formulas for area. So we know that rectangle or square is length times width. Okay, for a triangle, it is base times height divided by 2. All right, and remember that's the perpendicular base, okay, at a 90-degree angle. So let's work on this one here. Now I can see that I've got a right-angled triangle here, so that is my perpendicular height and base that I would need. So that's perfect. If you see models like this that don't have a right angle in that triangle, they'll indicate your perpendicular height somewhere either on the front of this, or they may indicate it here, back here, and give you the measurement for perpendicular height. So be careful with ones that look like this that don't have that right angled triangle in it. So this one here, we're going to go ahead and find the surface area of that together. So I'm going to find my 2 bases first. So I know in a triangular prism, the bases are the triangles. So I'll go ahead and do that first. Base times height, so 4 is the base, times height, which is 3, that's 12, divided by 2 equals 6 centimeters squared. And I know that if one is 6 centimeters squared, the other one is, because I know my triangles are matching bases. Now my rectangles may not necessarily be matching, so I've got to work with each rectangle individually. So let me do the top. I like to write it all out, like I said. And then I'll do the back here. And then I'll do the bottom rectangle. Okay, so that top rectangle, again, be really careful looking for your length times width. Okay, so it looks like I'm working with 5 times 2. 5 times 2 is 10, okay? And so I've got a top that is 10 centimeters squared. All right, so I'm not dividing by 2 this time because it's a rectangle. So rectangle is just length times width. The back here, it looks like I'm working with 2 times 3 here, which is 6. And then my bottom, so that's 2, and then this is 4. So I'm looking at 2 times 4, which is 8. So see, all my rectangles are actually different in this particular model. So that's why you've got to work really carefully looking for your length times width. Okay, and identifying those on those different rectangles. Okay, now I'm ready to add this all up. Okay, so I'm going to put those 2 together for 12. I always like to do mine in a tower in standard algorithm, just to make sure. I'm going to go ahead and put those together for 14 and add them up. I always, in case there's regrouping and things, I want to make sure that I'm doing my calculations properly. And this has a total surface area of 36 centimeters squared. Okay, so you'll have to remember today your formulas for the area of a rectangle, the area of a triangle, and remembering to use strategies like this. They've broken it down for you, maybe not in pictures, but in words, to help you keep all the faces separate and then adding them all together to find total surface area. So have fun doing that today. Be careful with your calculations, and I'll talk to you soon.